students, hope you all are good. So now we are going to start according to the title, what is pH and what does pH value tells you, that we are going to find out in this particular video. So let's start. What is pH? First of all, know the meaning of that pH. What is the meaning of that abbreviation pH? pH means potential of hydrogen, or it is also called as power of hydrogen. So how much H plus ion are there in your particular solution, that determines the pH value. Okay, and once you get the pH value, you can classify it as acid, base, or neutral. Neutral like pure water, not simple water. Pure water is your neutral, and the value is 7. That we'll discuss on the pH scale. So first of all, pH means potential of hydrogen or power of hydrogen. So how to calculate pH mathematically is defined as minus log H plus ion concentration. Now from where this concentration word came? This came from the bracket. Suppose I write X. In mathematics it is different. In chemistry it means concentration of X. Square bracket means concentration. So how I am going to read this? pH is equal to minus log concentration of H plus ion. So this gives you the value of pH. Let's take a short example. Suppose the H plus ion concentration that you are getting somewhere in your reaction is 10 to the power minus 5. Suppose this is the concentration of H plus ion. Then what you are going to do is substitute the value in the formula. The formula says pH is equal to minus log H plus ion concentration. Okay, whenever you are doing calculation, wherever in mathematics or in chemistry or in physics, do not skip the formula. It is compulsory to write the formula. So after this, substitute the value pH equal to minus log 10 to the power minus 5. Now according to the logarithm, log a to the power m is equal to m log a. I hope you know this formula. Log a to the power m becomes m log a. So minus 5 is going to migrate before log. So here I will use this minus, which is already there. Then comes minus 5 log 10, and remember, whenever it is not given to you, the base is taken as 10. And again a new formula, log base x is equal to 1, or we can say log x to the base x is equal to 1. So equals to minus to minus will become plus 5 log 10. Use this formula, plus 5 into 1, this will give you plus 5. It means the pH of a solution which showed you that the concentration of H plus ion is 10 to the power minus 5 has a pH value of 5. In this way you are going to get values of pH. Suppose examiner asks you that the H plus ion concentration here is 10 to the power minus 5. Okay. He may ask you the pOH value. Now this time power of hydroxide ion. He may ask you this. And the given value to you is H plus ion concentration is equal to 10 to the power minus 5. Nothing you have to do. First take out the pH. So as we have already calculated previously, pH value is equal to 5. Now remember a formula, pH plus pOH is equal to 14. Okay, so now substitute the value of pH. It's 5 plus pOH is equal to 14. Now use your mathematical mind. Implies pOH is equal to 14. Still in RHS, didn't change its place, so it will remain positive only, but 5 is going to migrate to the RHS side. From LHS, it is going to migrate to the RHS side, so it will become minus 5. So pOH value is equal to 9. I hope it is clear to you that even if H plus ion value is given to you, you can calculate the value of pOH also. Okay, so this is the value for pOH, 9. And if you want to verify your formula, pH means 5 plus pOH should give you 14 according to the formula, this formula. So 5 plus 9 is 14 equal to 14. So it is verified that your answer is correct. Okay. So I hope now you can calculate the value of pH or pOH. Remember this form. This is an important formula. pH plus pOH equal to 40. It may come for 1 marks. pH plus dash equal to 14, or pH plus pOH equal to 14. Sorry, pH plus pOH equal to dash. So in dash you have to fill 40. Question can come in anyway, as I already told you. Okay. Now, sometimes we are using indicators. We are also using indicator. What are indicators? Indicators are a weak organic compound. Now here I will tell you one more thing which will clear your concept regarding electrolytes also. So wherever the word is written weak, it means whenever you are going to dissociate it, it is going to break into some ions and some molecules. Remember, whenever something is weak, if you dissociate it, it will give some ion, it will give some molecule. For example, if you dissociate acetic acid, this will give you acetate ion plus hydrogen ion. But in the solution, you won't find only CH3COO negative, that is acetate ion, and hydrogen ion. They are not alone there. Something more is there, and it's undissociated molecules of CH3COOH. So in the solution, you are going to find these 3 species because it is weak acid. So weak acid, when dissociate, gives ions as well as molecules. And remember that the dissociation value for weak acids is maximum taken as 5%. If it dissociates to its maximum, it will only dissociate only 5%. It means 95% you are going to find molecules only. That is why weak electrolyte conduct, but they conduct in a very weak way. Conduction is very weak. Why? Because ions are less. And what about strong electrolyte? Suppose NaCl. So they dissociate completely into Na positive, Cl negative. So since they dissociate completely into ions, they will conduct. They will conduct in a good way, not like this acetic acid. The conduction will be more in strong electrolyte. Why? Because ions are there. Remember that conduction is because of ions only. Whenever something is conducting, it means ions are there. If something is not conducting, it means only molecules are there. Like glucose. If you talk about glucose, so it is taken as non-electrolyte because it does not give any ions. But weak, like acetic acid, gives some ions, so they are conducting, but they are conducting feebly, not in that way. Just like NaCl, it's a strong electrolyte. Okay. So weak organic compound means now pH scales or pH indicators, or simply indicators. What are indicators? They are weak organic compound. It means they will also dissociate into ions plus molecules. Now what happens? Suppose I am checking a solution that it is acidic or basic, then that particular acid is going to react with ions plus molecules. So whatever is the color in the pH scale, that is because of reaction between acid and ions. The color change that you get on the pH scale or the pH indicator or any indicator, it is because of the reaction between acid and what is present in acid? That H plus ion. And suppose it's base, what is present? OH negative. So it is because of these ions with ions of indicator, ions of the species that you are testing with the ions of indicator that you have taken, they give you the characteristic color. So whatever color you are getting, that is because of reaction between the testing species ion and the indicators ion. Okay, now let's go back to the value. This is your pH scale. This is your 7, 0, 40. Look at it very carefully. So 0 to 7 is your acid range, and 7 to 14 is your base range. Means if you test a species and the indicator shows a value somewhere between 7 and 14, then you will say it is basic in nature. Somewhere between 0 to 7, it means it is acidic in nature. In a short way, you can write somewhere 0 to 7 means acidic. If exactly 7 means pure water, that is neutral, neither acidic nor basic, and 7 to 14 means basic, basic natured. So this is how the indicators tells you whether a species is more acidic or acidic or basic. Now how to know whether it is more acidic or more basic? Go back to the extreme points. That is the answer. If you're testing and somewhere you get a point, suppose you're getting a point near to 0, near to 0. So this is also the extreme point and this is also an extreme point. So whenever the point that you get is near to the extreme, it means strong. Starting point, end point, that you have to focus on. Starting point and end point. If it is nearer to starting point, means more acidic. If it is nearer to the end point, means more basic. Somewhere between 7 and 14 means it is basic but not that much strong. 0 to 7, suppose the value comes here at 3, 3.5 or 4, then you will say it is acidic but it is not that much strong acid. Strong acid means it will be near to here, 1, like this, nearer to 0. And more basic means nearer to 14. Do not get confused that this is the starting point A. So many of you may think that it is more basic. Basic means nearer to the end point, extreme point, and more acidic means nearer to the extreme point, and its extreme point means here the starting point. So more nearer to the starting point, more acidic, more nearer to the end point, more basic. And what about 7? 7 means neutral. Now let me clarify what does the neutral means here. Actually we are confused regarding the word neutral. Pure water, I'm talking about pure water. Pure water is neutral. It does not mean that it is not acidic or it is not basic. Actually water is both acidic as well as basic. Acidic plus basic. Water is both acidic as well as basic. It is amphoteric in nature. In the last video, in the previous video, I told you what is amphoteric. Amphoteric means which shows you acidic strength, acidic nature as well as basic nature. Water is amphoteric means it is acidic, it is also basic. But what is the condition here? The condition is H plus ion comes out to be equal to OH negative ion concentration. So the concentration of H plus ion is equal to concentration of OH negative ion. That is why you are getting a neutral species, that is pure water. But if in water you add some acid, suppose in water I add some acid, so what will happen? Earlier H plus was equal to OH negative. Now H plus ion concentration will increase. So water will become little acidic. It depends how much acid you are adding to it. It will become acidic. And if you add OH negative means basic. You add some base to it. So when you add base to water, OH negative ion concentration will increase, because you know that according to Arrhenius concept, these are the species which gives out OH negative ion. So OH negative ion already present in the solution and you are giving more OH negative ion. So what will happen? If you add base to H2O, it will become basic. I hope it is clear that why I am telling that water is both acidic as well as basic. Water is both acidic as basic because it contains as much H plus ion as there are OH negative ions. A simple way to test is how we can prove that water is acidic in nature. So whenever water is made to react with any acid, it will give out salt plus water. And next, base plus water, again it gives salt plus water. So this is neutralization reaction. This water is different from this water. Why? Because here this water is behaving like a base. How we got it is behaving like a base? Because this is a neutralization reaction. When an acid reacts with a base, or we can say when a base reacts with acid, it gives out salted water. And when a base reacts with water, again it is giving salt plus water. It means here water is behaving like an acid. So if you do this type of reaction, you will find that with acid, water behaves like a base. With base, water behaves like a acid. How we got to know? Because the product that we are getting is the product of neutralization reaction. And in neutralization reaction, the species that are reacting is acid and base. I hope it is clear that water is amphoteric nature, and I hope it is clear that what is the meaning of neutral here. Neutral means it is acidic as well as it is basic, but the concentration of H plus ion is equal to the concentration of OH negative ion. I hope it is clear to you. So this was all about your pH scale. And in the pH scale, when you get in the lab, when you will get it in the lab, then there will be some colors. According to that color, you can find out. Okay, characteristic color are there for the different number. Suppose for one it is red, suppose for two it is yellow, or it is pink, whatever it is. Indicators have their color there. So by looking at the color, you can link it to the number assigned to it. Suppose 3 is for pink and you are getting pink, so it means the pH that you are getting is 3 of an acid. And I hope it is clear that why I am calling it as acid, because 3 is for acid, a range between 0 to 7. Suppose you are getting a characteristic color violet, and in the indicator it is already given to you that violet is for 30. Violet color is for 30. So just as you get violet color on your pH scale, you will say that the given solution is basic with a pH value of 30. You have to link that color to the number assigned. Okay. So in this way you can calculate pH. You can also do the calculation if you know the concentration. If you know the concentration, then you can know the value by using the formula pH equal to minus log H plus ion concentration, and then you can take out the value of POH also by using the formula pH plus POH equal to 14. And suppose you have indicator, then with indicator you can link the color to the given number and you can easily find out whether it is acidic or basic. But remember, last time what was the question in the board exam was they had given a scale with some reading. Like if you go through the last year paper, you will find out that question was like somewhat like this: A, B, C, and D, like this. I'm giving you some question. Try to find out the answer by pausing the video. Okay. Question number 1: which is more acidic? Question number 2: which is more basic? Suppose 2 questions are there. Pause the video and get the answer. Try to pause the video and try to answer, then I will give you the solution. Now I'm solving. See question number 1: which is more acidic? As I told you, you have to look for the extreme point or the starting point. So nearer to the starting point is A. Because I'm checking acidic part, so I will only look from a range from 0 to 7. I'm interested in the range 0 to 7. Why? Because I'm talking about acid right now. So, but in that also I have to check which is more nearer to the starting point. So to the starting point, A is there. Okay, so the answer will be A. Second part, which is more basic, which will show more basic nature. I hope now you know the answer. It's D. Again, pause the video because I'm giving a question to you. Which is least acidic? And question number 2, which is least basic? Kindly pause the video and try to find out the answer, then I will solve it. Okay, pause the video. Now I'm solving. Which is least acidic? Most of you will say that least acidic is B. Okay, most of you will say that the least acidic is B, but see, least acidic is D because it is more basic. I hope it is clear to you. Why I'm saying that it is least acidic? Because it is more basic. More basic means very low chances of acidic nature. If you say B, B has full chance of acid. It will liberate H plus ion. But here, very rare chance. Or you can say least acidic because it is not going to show acidic property. It is more basic. More basic means least acidic. So the answer here will be D. I hope now you can answer the second part, which is least basic, which is most acidic. Which is most acidic? It's A. So you can get confused with this question. Question number 1 and 2. Second part which I gave you. This is a little confusing. This is okay. Check the starting point, check the ending point. But here, which is least acidic, and actually the answer is coming from the basic part. We are checking acidic but least acidic, and we are getting answer from the base range 7 to 14. So in this way questions can come in examination. Keep your mind active, and in this way for least you have to check the weakest, strongest, least acidic, most basic, least basic, most acidic. In this way you have to answer the question. So these are questions which are normally from the pH scale. Otherwise if mathematical question come, that you can do, but last time this was the question. I hope this question is clear to you, and I hope you won't have any doubt regarding pH scale, pH value, how to calculate, how to check. Okay, so keep going, keep studying. Thank you.